In this video, we're going to go over the concept of a voltage divider circuit, which sounds incredibly intimidating, but I promise you, you're going to have the concept down mastered by the end of this video. It's relatively straightforward. So let's say we have a circuit here. Sorry, I had that written already. Let's say we have just a normal old circuit. We have a battery supplying a voltage Vs and a resistor in series with the battery that has a resistance value of R1. And for the sake of this video, actually first off, let's say if we were to have a switch up here, and I close the switch, and when I close the switch, the voltage dropped across the resistor would of course be V sub S. But let's say for the sake of this video that R1 would burn up instantaneously if it has V sub S supplied across of it. So obviously we can't have Vs supplied across R1. That would be unsafe for our circuit. So what's one way, besides getting a new battery, what's another way we can make the circuit safe and not have R1 burn up? Okay, so I hope you said put another resistor somewhere in the circuit. But how would we connect that resistor? Would we put it in parallel with R1? Because if I put it in parallel, notice they would still have Vs dropped across both resistors because they're in parallel. So parallel is not going to work. We're going to have to put some other resistor in series with R1. We're going to call this resistor value R2. So now we're going to essentially choose R2 such that the voltage is divided across R1 and R2 in such a way that R1 maintains a safe voltage value, something less than V sub S. So let's actually do some math here and see how we can calculate an R2 such that the voltage across R1 is a safe voltage and is less than V sub S. So let's say we need a voltage V1 across R1. Say for some circuit that we're building, we need a voltage drop V1 across R1. Okay? Before we can find specific voltages, we know that the voltage supplied to the circuit, V sub S, according to Ohm's law, let me write a better V. V sub S must be the current through the entire circuit. I'll draw that just as like arrows going through the whole circuit and returning back to the battery. This is just a current I multiplied by the equivalent resistance of the circuit, which is obviously just R1 plus R2 because they're in series with one another. And I can solve for the current through the entire circuit. I get that is Vs over R1 plus R2. That must be the current through the circuit. Now let's say I want a voltage V1 across R1. So I could write Ohm's law for this case is equal to the current through R1 multiplied by the resistance value of resistor number 1. Now notice the current through R1 is the same current that goes through the whole circuit. So I could substitute this value in for I over here. And I obtain the following expression. I would get R1 times V sub S over R1 plus R2. Now, notice here, I can now solve for V sub 1. V sub 1 would be, I already have it solved for it, I apologize. I could actually solve for a resistance value R2. By solving for R2, I find a resistance value that I can put in this circuit such that the voltage drop across R1 would be V sub 1, and the circuit would therefore be safe for operation. But your textbook or your professor probably gives you a different formula. They show this as, actually I'll show you exactly how to obtain it. I'm just going to delete some stuff just to make some more room. So make sure you have this stuff written down over here. So this may be just enough, a good enough, a far enough derivation right over here to solve for R2. But sometimes in textbooks, you'll see this as a different form. Maybe when I invert this, I get 1 over V1 is equal to R1 plus R2 over R1 multiplied by 1 over V sub S. And I could divide through by R1, and I get 1 plus R2 over R1 times 1 over V sub S, and that's 1 over V sub 1. And now I could solve for V sub 1, and that would be, let me think about this, I would just get V sub 1 must be equal to, if I multiply both sides by V sub S, over 1 plus R2 over R1. And this is probably what you see in your textbook, the equation for a voltage divider circuit. So this is literally telling us, if we want some desired voltage, V sub 1, across resistor 1, we have to choose some resistance value, R2, which we can solve for using this equation, such that this is the resistance value, R2, that we can choose, such that a voltage drop, V1, is across resistor number 1. So this is where it essentially comes from. We find the current through the entire circuit, and we use that current to get voltage drop V1 across R1. All voltage divider circuits is just safely finding a resistance value R2 such that the voltage drop across another resistor is a safe value for the circuit. So hopefully that makes some sense. Here's some intuition behind where the formula comes from, and I hope that helped.